Hello everyone, welcome back to this video lecture series of location of ICR. In this particular video lecture, we are just going to locate the ICR of any given mechanism. Let us start with a very simple one in which we are having a link AB as a rod which is going to slide down the vertical and the horizontal along the points A and B. When we want to locate the ICR, that is the instantaneous center of rotation for this given link, we just have to understand one thing, which is the angle of this given link with any of the horizontal or the vertical. Based on that, we could be having our velocity directions, and later on using those velocity directions we can locate the ICR. Now if I say that the link is going to move in such a way that the point B is moving in the horizontal direction with the velocity VB in this way, so it is quite obvious for us that the point A on the same link shall be moving downwards somewhere along way in this particular direction along the surface. So this becomes my VA. Now as far as we know, we have learned in the previous lecture that once we get the location of the location of velocities of any 2 points on a given link, I can locate the ICR for that given link. So here we know the velocities directions for the 2 points, that is A and B. A is moving downwards, B is moving in the horizontal rightward direction. So using that, I can simply just draw perpendiculars from the given velocities, and the intersecting point for both the perpendiculars from those velocities will give me nothing but the ICR. So let us have a look where it is going to be located. So I'll just draw a perpendicular over here. And in the similar way, a perpendicular from this side. So the intersection point is nothing but the ICR AB. This I'll just show it over here. These are the perpendiculars. So when we are locating ICR, we just have to make sure that we know the direction of velocities of any 2 points on the given link. Now in this particular lecture, I would suggest to people to just learn by doing something. So it is advisable that during this video lecture itself, you may pause the video and try to draw things wherever applicable. Just in the next example, we are having another link over here, a sliding link. Again, there are 2 surfaces, but this time now we have a horizontal surface and an inclined surface where the link is supported. So for this purpose, I would like you people to pause the video over here and try to draw the velocities of both the points. Consider the point B again moving in the horizontal rightward direction. So I hope you must have paused the video over here, and now it is time for me to just show you what will be the directions of the velocities. So as usual, again my point B is moving along the surface horizontally. Same way, at this given inclined surface, I will be having my velocity VA. So I hope you have understood this part. If B is moving in this direction, definitely A will also be pulled along this particular link, and A has to definitely follow the path of this vertical or inclined surface. Now what is the next step? Yes, it is just to draw the perpendiculars from these 2 given velocities. So let us just draw that and find out the velocity intersections. So I'll be just drawing a perpendicular from the velocity VB, and from this given point I'll try to draw the perpendicular for the velocity VA. See, it is very important for us to get the understanding of what exactly is the motion. in these two cases that we have already covered, we have got the velocities VA and VB both as translation motion. So this was a classic case of having both the velocities in the translation motion. So you must be wondering, how is it possible that if 2 points are having translation motion, it will be having a center of rotation? So yes, exactly, this is an imaginary point along which my points A and B are assumed, or we can say we can understand it as rotating around this point IAB with an angular velocity omega AB. Okay, let us move further. We will now move on to this particular example, which we had actually discussed in our very first video lecture. This is again the slider crank mechanism. Here the crank is OA, which is moving in, or rather rotating in, anti-clockwise direction. So based on that, definitely the slider B will also be moving in the horizontal direction. Let us understand how that is going to happen. For that purpose, I would just like to draw OA. Using OA, I would like to draw the velocity of A. So again, we will go to the same concept of us, which is V is equal to R omega. So if I want to find out the velocity, linear velocity of A, I just have to need to know the omega OA, which will very well be given in the problem most of the times, and the distance OA. So based on that, if I know all these things, then I will be able to find out the velocity VA, linear velocity, and that has to be perpendicular from the point of rotation. So let me draw a perpendicular from the point of rotation from point A. So this is the perpendicular for point of rotation for point A. So this may be the velocity direction VA. Now the problem over here is that if I am trying to draw the velocity VB may be going towards the inside direction. Let us say this direction. I'll rather draw it over here for simplicity. So this becomes VB. In this case, people may be able to have a doubt in their mind that how is it possible for us to get the velocities intersecting this time. So we are not going to intersect the velocities over here. We are going to intersect the perpendiculars of these velocities, and that will just give us where exactly is the location of the ICR. Now before we proceed ahead, let us understand a few things which will make our I would say the understanding of this concept clear. Whenever we are into such a situation, first just identify all the links and their center of rotations wherever possible. Like in case of OA, the center of rotation is at O. So OA is a purely rotating object or a rotating link. Same way, if we are talking about the slider B is just a translation motion which will have its center of rotation somewhere in infinity. So let us not worry about that infinite distance radius right now. We will just understand that it is the link AB, which is the connecting rod, that is not either rotating simply or not simply just translating. It is a combination of both. Why? Because point A is purely rotational and point B is purely translation. So how do we do that now? Again, I have got the direction of VA, which is perpendicular. I have got the direction of VB along this slider. Now points A and B are both on the connecting rod. So if I draw and intersect the perpendiculars from VA and VB, I will be able to locate the ICRs for the same. So let us try and draw that. So when we do this, we will be having our intersections of these velocities, perpendicular of the velocities somewhere over here. So this becomes the ICR for my link AB, along which I may assume that the link AB is rotating along only this given instant. Let us be very specific, which is at given theta over here. Let us move further. Now I will try and explain something about three links, which is definitely not there right now in our syllabus, but just for our understanding purpose and to get everything clear, we will just go for three links of the mechanism. In this three link mechanism, we have two cranks which are connected by a connecting rod, and these two cranks are rotating. So we may have this link rotating in maybe anti-clockwise direction, and this one will be rotating in the clockwise direction. So for any given particular instant, let us try and draw the perpendicular velocities of these rotating links. So again, I would like you people to just pause the video and try to get the direction of velocities for A and B along point O and C respectively. So I hope you people have paused the video, and now after resuming, I would just give the direction of the velocities and just try to see if you have got the same. From point OA, I would just try and get the perpendicular. So OA is my reference. I will get the perpendicular, which will give me velocity VA over here. And in the same way, this is the link BC, and along that I will just get the perpendicular for VB. So now in this case, again, what has happened? We have to just find out the perpendiculars of these velocities. What we have just done is getting the velocity directions along points O, which is the rotational point for the link OA, and along point C, which is the rotational center for link BC. Try and get the perpendiculars, and wherever the perpendiculars are intersecting, definitely that becomes the ICR for the link AB. So I don't know why I'm finding out the ICR for link AB is just because that I want to find out the instantaneous center of rotation for this given link for this given instant. So let us try and go for that. I'll try and locate it by getting the perpendiculars. So draw perpendiculars from both the velocities. So this is the perpendicular drawn from VB. Now I'll try and draw the same thing from VA. So wherever I have got the intersection, this is nothing but the ICR for the link AB. I may assume that ICR AB is the point from where my rotational motion for AB is happening for this given instant. Let us again focus on this problem now, where we again have three links, which is very similar to the one previously done, and I would like you again to pause the video and locate the velocities first of all, and then locate the ICR. So you may draw the entire thing which we have completed over here for same way in for this particular problem, and then after resuming I will just give you the same explanation. So let us try and get the location of the ICR for the link AB over here, which is under general plane motion. So general plane motion, okay, yes, before we proceed further, there might be a question in someone's mind that why is AB under general plane motion when the point A is also rotational and point B is also completely rotational. So in this case, the answer is that point A is under rotational motion, which is for sure, but it is at different angular velocity. Same is the case of point B, which is at different angular velocity. So the actual angular velocity of points A and B, when we are comparing it as far as the link AB is concerned, that angular velocity could be different. So we just want to find out what is that particular angular velocity at which my link AB is rotating about that given point. So first of all, let us find out what is the direction of velocity for the point A. So I'll just draw a perpendicular from my link OA, and in the same way I will try and draw perpendicular from the link BC, which is, let us say, somewhere over here. Now this is my VA, this is VB. Try and draw the perpendiculars for both of the velocities, and wherever they intersect we will get nothing but our ICR, definitely for link AB. So yes, this is the particular location ICR IAB. So just understand that if I wanted to find out the relation between the velocities of VA and VB, there would have been a common angular velocity omega AB, which will help me out to get the velocity VB. In this kind of a question, we may have been given the omega OA, and we might have been asked to find out what is the omega BC. Definitely the lengths and everything will be given. Also the angles will be given. We will just be able to find out using geometry the lengths from I to A, I to B, and then proceed with the problem. Now coming to the last example for this particular video. In this, we want to find out the velocity of point C. Maybe in this given example, I just want you to find out the direction of the velocity of point C. Since we are not into solving the problems, just I want you to find out the velocity of the direction of the velocity point C. So how do we do that? Again, I would like you to pause the video and get the velocities of all the links that we know the direction already. So I think you must have drawn that. Over here, if I consider, I would like to identify first of all the various links, the motion for that, this which is OA. OA is purely under rotational along point O. So if I try to find out the velocity at point A, it will be just perpendicular. V is equal to R omega. So this is my VA, and same way VB, because it is completely constrained under these two surfaces, it has to move in the horizontal direction, maybe positive or towards the rightwards or the leftward direction. So that is not the question. More important thing is VB will be moving in the horizontal direction. Now I know what all the directions are, and looking at these two directions, the points A and B, if you observe clearly, it is also a part of the link BC. BC is the complete connecting rod, and A is just an intermediate point, a random intermediate point on the same link. So in such a case, what we can do is, if we know the velocity direction of any two given points on the same link, we can simply draw perpendiculars from them, and intersection of these perpendiculars will help us find out the ICR. So I'll just go with my regular method and draw the velocity, the perpendiculars to the velocity. Same way over here for VA. So the two perpendiculars are drawn, and the location will give me I, which is for IAB. But because this entire link is BC, I would rather write this as IBC. Okay, it's one and the same thing, but we would just like to we can say always show this point as the complete link, for the complete link. Now I know the location of the ICR for this given link, which I may assume to be rotating along this given point, which we have already defined it as the ICR. If I want to find out the velocity direction, or maybe even the velocity of any other point on the same link, I can use the same ICR for this given instant, join those two points, and now from these 2 points that I've joined this line, if I draw a perpendicular, this perpendicular will give me nothing but velocity at the point C. Velocity at point C. So in this given case, maybe I will have to find out, first of all, I may be given omega OA. Based on omega OA, I will be able to find out, let us say, the velocity VA, and with the help of velocity VA and the dimension I to A, I will be able to find out the omega of BC, and using omega BC and IC as the dimension, I will be able to find out velocity VC. So I hope you people have found out this particular video as very informative, and it has cleared the doubts in whatever way it was. If you still have any doubts, you can approach the teacher and get it solved immediately. Thank you.